Okay, in questions 14 through 17, these are the first part, the intro to unit number 4. This was on factoring. So let's recall, for factoring, there are 3 types of factoring that you were held accountable for. One was greatest common factor. So that's where you're looking to see, is there a number in common? In this case, there's a 4 in common, and there's an x in both. So you're going to pull out the 4 and the x, and then you're going to write what's left. And again, this is called, what I like to refer to as undistributing. Okay, because we know how to distribute. You would normally distribute. So we're going backwards. We're pulling the term out. Okay? Then, once you check for greatest common factor, if you have 2 terms, then you would want to look for a difference of squares. Okay? Difference of squares, the first term and the last term both have to be perfect squares. And the middle term needs to be subtraction. Then, if that happens, it's going to factor into conjugates. Remember, conjugates are the same 2 binomials, just one's adding, one's subtracting. So what you do is you take the square root of the first term, which is square root of 4x squared is 2x, so 2x and 2x. Square root of 9 is 3, so that's 3 and 3. And then 1's minus, 1's plus. That would be a difference of squares. And then a last one would be 3 terms. If you had 3 terms, you'd be doing the opposite of FOIL or guess and check. So you would start with 2 sets of parentheses, and remember the first term times the first term has to get you the first term. The last term times the last term has to get you the last term. And then your outers and your inners have to get you the middle. This is the first, this is the outers, inners, this is the last. Okay? So, using that idea, looking at number 14, first we're going to check for a common factor. So it looks like we have a 1, a 3, and a 2. Not a common factor there. And looks like there's not an x all the way through. So since there are 3 terms, we're going to be doing opposite of FOIL. Okay. So here we're going to have 2 sets of parentheses. The first term times the first term has to get you the first term. So it looks like that's got to be x. The last term times the last term has to get you the last term. So what are factors of 2? That's only 1 and a 2. And since your signs are all positive, these would both be plus. Okay. Number 15, we only have 2 terms here. First, we should check for a common factor. So we got a 25 and a 4. There's not a common factor there, and there's not an x in both, so we have no common factor. Is 25 a perfect square? Yes, it is. Is 4 a perfect square? Yes, it is. And we've got subtraction. That means these are going to factor into conjugates. 1 positive, 1 negative. The first term in each has to be the same, and it has to get you 25x squared. So that's going to be 5x and 5x. The last term in each has to be the same, and it has to get you 4. Got to be 2 and 2. And recall here that your outers would be negative 10x, your inners would be positive 10x, and they just cancel out. That's why there's no middle term. On 16, doesn't look like we have a common factor again, so it's got to be the opposite of FOIL. So the first term times the first term has to get you the first term. So factors of 2 are just 2 and 1, so one of these has to have a 2, the other one's going to be a 1, x. Then we need the last term times the last term to get us the last term. So we need factors of 5. Okay? Now because it's a negative 5, one of these is going to be plus, one's going to be minus, but we can't put those in because the first terms are different. So we know it's going to be 1 and a 5. So the question is, since there's a 2 here, do we want the 2 to multiply by a 5? Or do we want the 2 to multiply by the 1? Well, we're trying to get a 3. If we multiply 2 by 5, we're going to get 10. It's going to be hard to get back down to 3. So let's try the 2 multiplying by the 1, and let's put the 5 here. So this would be 2 times 1, which is 2x, 5 times x, which is 5x, so 2x and 5x. Hey, we can get a 3x out of that. actually we can get a negative 3x out of that if the 5 was negative 5x and this was a positive 2x, because negative 5x and positive 2x combined together get you negative 3x, and that's the correct middle term. Okay? So there's your factoring on that one. The last factoring, number 17, says factor completely. So here, again, we're going to look for a common factor. 3, 6, and 3. Looks like there's a common factor of 3, and each of them have an x, so we're going to pull out an x. So since this is a common factor, this is undistributing, which means we're going to have something plus something minus something. So we're going to take the 3x out of 3x squared, which is just going to leave you with an x squared. Remember, this times this better get you back to that. So take a 3 out of a 6. That goes in twice. Take an x out of x squared, leaves you with an x. And then how many times does 3x go into 3x? It goes in there one time, or 3x times 1 is 3x. Now we should check to see if this factors. Are there factors of negative 1 that can get you positive 2? Doesn't look like it, because it's just 1 and 1, but in order for that to be a negative, you'd have to have a positive and a negative, and you can't get a positive 2 out of a positive 1 and a negative 1. So here is your final factoring on number 17. Okay? So that's the review of factoring.